1 of lab 3. Says select the first ICMP echo request message sent by computer, expand the IP part of your packet. Over here is the source IP. So for 2 within the IP packet header, what's the value of the upper layer protocol field? It'd be right over here, and that would be ICMP OX01. How many bytes are in the IP header? So there's going to be a total of 60s. Actually, IP headers up here. It's going to be 20 bytes. Total length is 65. So 65 minus 20 equals 45. And that's how many bytes are in the payload for the datagram. 4, has the IP datagram been fragmented? There should be over here. Yeah. So fragment also said 0. So no, it's 0. So the packet is not fragmented. Moving on to alright. So number 5 says which fields in nice IP datagram always changes from one datagram to the next. So when you're checking these, you can see that the header checksum. See right here, the header checksum and the identification always changes. Which fields stay constant, which fields must stay constant, and which fields change. So when you do this, you see the fields that stay constant are the IPv4, the length of the header, the source IP, the destination IP, and the upper layer protocol, and they must all stay constant as well. The fields that must change are the header checksum and the identification. The header checksum must change because any modification to a certain fields in the packet header would invalidate the previous checksum, and the identification must change because when fragmentation occurs, it ensures fragments can be properly reassembled at the destination. Number 7, describe the pattern you see in the values of the identification field in the IP datagram. You can see at each time with the identification. See how it goes from 9. See how it goes from 9 and it goes to A. So the pattern of the field increases by 1 in each echo request. Next, with the packets, find the series item. Okay. So I guess this would be the first one. The value of the identification field. The time I did it was time to live was 64, and the identification was 6556. Do these values remain unchanged for all the ICMP exceeded replies sent to your computer by the nearest router? Why? So we were to click here. The identification changes. Identification changes. This is because they have the same values, so the replies must be fragmented in the packet. The TTL doesn't change, and that's because the TTL to the first hop router is the same. Now on to fragmentation. So we're going to find the first ICMP echo request message sent to your computer after you change the packet size. After we change the packet size. I have it marked down. It would be this one right here. This would be the first one. And it has been fragmented because it also says more fragments right there. Print out the first fragment of your fragmented IP datagram. What information is the IP header indicate the datagram has been fragmented? So the flag set for more segments shows that the diagram has been more fragmented. The fragment offset 0, which indicates that the first fragment rather than the latter fragment where the value is set to 1480. So we can check right here. You can see this offset is 1480. The total datagram is actually 1500 right here. 12. Print out the second fragment of the fragmented IP datagram. What information in the IP header indicates that this is not the first datagram fragment? Are there more fragments? How can you tell? Well, the second fragment has an offset of 1480. As you can see when I do this, 1480. And there are no more fragments because it doesn't have the flag set for any more fragments after that. What fields change in the IP header between the first and second fragment? Well, the fields that change are the length. Either this, it would either just be the length, the flag set, the fragment offset, and then the header checksum. And now we could go check. Let's say now after we set the pack size to 35,000. So that would go into, let me see it over here as well. 2646 right here. You can see that 3 fragments were created and they're right here. The fields change. So number 15 would be where the fields change in the IP header among the fragments. The fields that change are the fragment offsets 1480, and 520. The first two had the packet length of 1500 and more fragment flag set, and the last one has a length of 540 and no flag set. And that is part 1 of Lab 3.